All right, so let's start the next topic now, which is statistics. There are two parts of statistics that we will be covering. The first one, most of these concepts you know already, finding measures of central tendency like mean, median, mode. And then the second thing, measures of dispersion, which include range and standard deviation. Range you already know about. We'll talk briefly about standard deviation as well. So let's start with this. Uh, Data set is basically just a set of values written like this. So if it's a collection of values. So whenever they refer to a data set, that means you have a number of values written like this. Okay, so this is a data set 22557, for instance. You need to be able to find mean of data set like this. How do you find mean? Add up all the values, divide by the number of values, right? That's how you find mean. What about the median? Median is the middle value of the data. If you sort the data, right, in ascending order or descending order, you can do it in either way, least to greatest or greatest to least. Whatever is the middle value, that's the median. Okay, now there's a small detail here. Sometimes the number of values is odd, sometimes the number of values is even. You can use this formula to find the median, n plus 1 over 2. This is the position of median. N plus 1 over 2, this is going to be the position of median. Where n represents the total number of values. The total number of values is n. If you have 7 values, for instance, if let's suppose n was 7, what would you get? 7 plus 1 over 2. Whatever is the fourth value, that will be the median. Okay. In when it's sorted in ascending or descending order, the fourth value will be the median. Okay. So when the number is odd, when the number of values is odd, you get an exact position of that value. Okay. But if the number of values is even, for example, in this case, the number of values is 6. What do you do in this case? If n is equal to 6, you say 6 plus 1 over 2, and that gives you 3.5th value. Now, what does that mean? 3.5th value does not exist, right? The number of values is supposed to be in integers. When it's 3.5, you say you take the fourth value and the fifth value and find their average. I'm sorry, third and fourth. 3.5, you take the numbers around that. Third value plus the fourth value divided by 2. Average of that, right? What's the third value in the data? 5. The fourth value is also 5 in this particular data set. You'll say that's 5 plus 5 over 2. Okay? If it was, for instance, 2 to 4, 5, 7, 7, what would be the median in that case? 4 plus 5 over 2, and that's 4.5. 4.5 would be the median. Is that okay? All of you get this? Right? If it's an odd number, you get an exact number. If it's an even number of values, you get 0.5 like this. You take the average of the two numbers around that, third and fourth in this case. Okay. All right. Mod is just the most repeated value in a data set. I'm sorry, this data set got changed here. Okay, no, sorry about this. Let me just change this a little. Let's say this is 2, 2, 5, 7, 9, 13. If you have this data, what's the mod of this data? It's 2. It's the most repeated value, right? Sometimes you can have multiple modes as well. That is possible. So for instance, if you had 13 and 13 here, you would say 2 and 13. Both of these are modes of this data. So you can have multiple modes as well. Is that okay? All right, let's move on. What's the range of a data set? It's just the highest value minus the lowest value. So in this case, you can do 7 minus 2, and that's the range of the data. Maximum value minus minimum value. All right. Okay. Now, there's another measure of dispersion that basically quantifies spread of the data. What does range represent? Range represent how much variation is there in a data. So for instance, if you have a data like this, 3, 4, 5, 6, 7, what's the range of this data? 7 minus 3, which is 4. As opposed to if you had these values 30, 40, 50, 70, 100, what's the range of this data? 100 minus 30, that's 70. What are these values telling you? These are telling you the spread of the data, the variation in the data. The first data is less varied, there's less variation there. In the second data, there's more variation. Is that okay? Range tells you about the variation in the data. There's another measure that also tells us variation in data, and that's called standard deviation. Okay. Now in SAT, you do not need to know how it is calculated. There's a formula that we have for standard deviation, which again you will study in A levels, but in SAT, it's not required. You will not be asked to calculate standard deviation. Okay. You will just be supposed to compare standard deviations of two data sets. Now, what does standard deviation represent? Standard deviation basically represents how spread out the values are in relation to the mean. Roughly, you can interpret standard deviation like this. You can say it's the average distance from mean. Average distance of the values from the mean value. That's a rough interpretation of standard deviation. That's how you can understand this. Average distance from the mean. Now, if most of the values in a data are close to the mean, the standard deviation will be lower. If most values in a data are away from the mean, standard deviation will be bigger. Is that okay? Zara, what did I just say? फिर स्टैंडर्ड डिवीजन कब ज्यादा होती है कब कम होती है स्टैंडर्ड डिवीजन कब कब ज्यादा होती है और कब कम होती है So standard deviation roughly measures average distance from the mean. If the values are far away from the mean, standard deviation is bigger. If the values are close to the mean, overall, the standard deviation is lower. So if you look at these two data sets, 2, 2, 5, 5, 7, 7, the mean of the first data is going to be somewhere around 4.78, I think. Can somebody calculate that quickly? 14 and 14, 28, 28 over 6, 4.67. What about the second data set? 33 over 6, that's 5.5. Okay. Now 4.67, that's the mean value. You have to look at the distances from this mean value. 2 is 2.67 units away. Similarly, 7 is 2.3 units away, and so on. What about the second data set? From 5.5, these values are all pretty close to 5.5. Is that okay? That means the standard deviation of the second data set is going to be lower. This is lower standard deviation. And the first data is going to have higher standard deviation because the first set of values is generally far away from the mean as compared to the second set of values. Is that okay? If you were to actually calculate the standard deviations, which again, you do not need to know how to calculate them. If you were to calculate them, you will figure out standard deviation of the first one is 2.28. The second one is 0.83. Where these values come from, you don't have to know that. Okay, there's a formula for this. For SAT, it's not required, but it's just for reference that the standard deviation for the first one is indeed higher as compared to standard deviation of B. Okay. So what does standard deviation represent then? Average distance from the mean. Okay. Let's have a look at some examples. We have two data sets, data set A and data set B. Which statement correctly compares the means of data sets A and B? The mean of set B is higher than the mean of set B. Mean of B is less than mean of set A. Mean of B is equal to the mean of data set A. There's not enough information. Now, one possibility is what you are doing right now, calculating the means of both of these data sets. But is there a quick way of just figuring this out? Look at the values. 26, 32, 38, 44, 50, 56. The second set of values is also all the same. There's only one difference. There's another 26 here. Okay. Which mean is greater? A. Why? Sorry? कैसे पता चलेगा? Calculate करके? No, but without calculation. So, but what if we had 100 here? Then the second mean will be higher. So basically, you think of it this way. Both the data sets are the same, except for one addition to the mean value. To this data set, that's 26. एक value और add होगी इसके अंदर. Now that value is either going to make the mean lower than it was before or bigger than what it was before. How do you figure out if the mean is going to get lowered or it's going to become bigger? How do you figure that out? The mean of the first data set, it's going to be somewhere in the middle here, right? Let's assume it's 41, which is it actually is going to be. But even if you were not to calculate that exactly, randomly कह लें कि अच्छा let's say 35 होता. Let's assume. The new value that we are adding, that's lower than the mean. So the mean is going to get lowered. If the new value that we were adding, if that was greater than the mean, if that additional value was, let's say 53, that's greater than the mean, then the mean would become larger than it was before. So you can just look at this data and see कि अच्छा बाकी सारी terms तो same है, बाकी सारा data same है. The new number that is added, whatever is the mean of all of these values, 26 is going to be less than that. Because of that, the mean of the second data set is going to get lower. Is that okay? If that additional value was greater, let's say 70, the mean would be bigger because this value would be bigger than the mean. So the mean would get bigger as well. Does that make sense? When a new value is added to a data set, it brings the mean up if it is greater than the existing mean, and it pulls the mean down if it is less than the existing mean. So 26 was added. Whatever was the mean before, since 26 is the lowest value, mean is definitely going to be something bigger than this, right? So that means the mean of the second data set is going to be less. So that's option B. Is that okay? Because mean of data set B is less than the mean of data set A. No problem? So this is something that you should keep in mind because you can do some problems without actually calculating the means. You can just look at the data and figure out what mean is going to be bigger and which is going to be lower. Okay, smaller. Let's have a look at this one. इस तरह के problems आपने O levels में भी किए, I think. Adding a value to a data set. The mean weight of a group of pandas is 200 pounds. A new panda weighing 230 pounds is added to the group, increasing the mean to 205 pounds. How many pandas were in the original group? How do you figure this out? So what are we looking for? How many pandas were there in the original group? Let's call this number something. Let's call this number n. Okay, the number of pandas in the original group. What was the mean for them? 200. The original mean was 200. How do you find mean? Sum of all values divided by n, sum of values divided by n equals 200. So we can say sum of values would be 200 times n. Initially, that will be the sum of values. Is this okay? Sum of values over n is 200. If we take n to the other side, it becomes 200 times n. That's the initial sum of values. Now what happens is another panda is added. And this one has a weight of 230. Now the original sum of values was 200n. You add 230 more to it. What's the total number of pandas now? N plus 1. So this mean has to equal 205 now. That's the new mean. So new mean is equal to new sum of values divided by the new total number of values. The number of values is now one more than it was initially. So that's n plus 1. Sum of values was 200n earlier. Now it's 200n plus 230. And that should give us the result. You can see whatever that turns out to be, 200n plus 230 equals 205n plus 205, and that gives us 5n equal to 25 and n equals 5. So there were 5 pandas in the original group. Is that okay? Now, sometimes you have frequency tables as well. You've seen this before in O-levels as well. Now, they could be in column form or row form, it doesn't matter. The frequency table summarizes the values in the data set. Which of the following statements correctly compares the mean and median of this data set? Now, remember how we find mean of a data set like this? Sigma fx over sigma f. All of you have done this, right? Sigma fx over sigma f. What does this frequency table represent? Value 5 has a frequency of 6. What that means is 5 is coming 6 times. So in raw form, the data would look like this: 5, 5, 5, 5, 5, 5, right? It comes 6 times. And then 8 comes 5 times. And then 9 comes 2 times. And then 12 comes 4 times. This is what the actual data looks like, right? In table form, how can we do this calculation? Since 5 is coming 6 times, rather than doing 5 plus 5 plus 5 plus 5, we can just do 5 times 6. That's what fx represents, frequency into x value, right? So we say this is x, this is f. What's f times x? 5 times 6, that's 30. 8 times 5 is 40. 9 times 2 is 18, and this is 48. And then you add all of these values, that's sigma fx, right? What's that? 70 plus 136. 136 is sigma fx, and that's what you would have gotten if you were to add all of these values up. This formula just makes things quicker like this, okay? That's the numerator now. 136 divided by the number of values. Now the number of values is 6 plus 5 plus 2 plus 4, sigma f, the sum of all frequencies, which is 17. And that should give you the mean. What's the mean? 8. Okay. Mean is 8. What about the median? Median कैसे find करते थे? What was the formula we just discussed? N plus 1 over 2. In place of n here, now we have sigma f, right? Because that's equivalent to n. The total number of values is what? 17. 17 plus 1 over 2, ninth value should be the median. What's the ninth value? The first six values are fives. And then from 7 to 11, all of these values are eights. So median is 8. Mean and median both are 8 in this case. Mean is 2 greater than the median? No. Mean is 1 greater than median? No, no, no. Mean is equal to the median. That's option C. Okay? So you should be able to calculate mean of a frequency from a frequency table and also median from a frequency table. All of you know how to do this, right? Okay, let's have a look at this now. The masses in kilograms of 21 rock samples were recorded and summarized in the dot plot shown. It was found that the sample with the greatest recorded mass actually has a mass that's 4 kilograms more than what was recorded. If the record is corrected, which of the following measures the data will increase? The sample with the greatest recorded mass. What's the greatest recorded mass? 14. There's one point there as well. The greatest recorded mass is 14. This point, right? It actually has a mass that's 4 kilograms more than this. So this value is written wrongly here. The actual value is 18. If you correct this, which of the following measures will increase? So whatever is the mean, median, and range from this data, if we were to correct 14 and make it 18 instead, is the mean going to increase? Mean will increase, right? Because instead of 14, we have 18 in the numerator, right? 18 is going to be added. So mean increases. What about the median? Median increases. Median just represents the middle value of the data. Number of values is 21. 21 plus 1 over 2, that's the 11th value. It doesn't matter if it's 14 or 18 or 20 or whatever. 11th value is still the same. That is going to be this value, 6. Right? 14 does not have anything to do with the median, right? It's not used in that calculation. So median remains the same. It does not change. If there was an additional data point, then the median would change. Okay, but if the number of data points is the same as before, then it's only the 11th value that matters here. What about the range? Range is maximum value minus the minimum value. The maximum value has changed, so the range will also change. Okay, so it's 1 and 3 only. Is that okay? Okay, sometimes you have bar graphs like this as well. Take 30 seconds, read the question statement. So you have these two data sets. Each of them consists of 155 values. Vertical axis has frequencies. You can see that here. Horizontal axis has values. How would you compare standard deviations of dataset A and standard deviation of data B? What does standard deviation represent? Average distance from mean value. Just by looking at the data, can you guess where the mean of the first dataset is going to be? Somewhere in the middle, right? Maybe 2, because more values are towards the left side. 2 or 3, it will be between 2 and 3, right? Mean value for the first data. Does that make sense? Where is the mean of the second data going to be? That's also going to be somewhere in the middle. In fact, this is perfectly symmetrical, so the mean is going to be right in the middle. That's 3. Right? Roughly, that's where the mean is going to be. Now, Are the values closer to the mean overall in the first data set or in the second data set? If you were to compare the two, values are closer to the mean in data set A as compared to data set B. B में देखें, you have most values at the ends. And then as you get closer to the mean, you have less number of values. Okay. Which of these two data sets is going to have a higher standard deviation? B. Distances mean से ज़्यादा है वहाँ पे. So standard deviation is going to be more there. Okay. So what do we say? Standard deviation of data set equal less B. Okay. You don't have to do any calculations here. You can just look at the data and say that these values are much closer as compared to the second data set. There are 35 zeros in this data. There are 30 ones in this data. There are 35 twos in the data. There are 25 threes in the data, and so on. In the other data, there are 35 zeros, 35 sixes, 25 ones, 25 fives. Mean is in the middle. Most values are away from the mean. In this first case, most values are not away from the mean, at least comparatively to the second data set. Okay. Now, sometimes you have histograms as well. You have this histogram that summarizes. Now, in a histogram, you can have frequency on the vertical axis. Sometimes you can have frequency density on the vertical axis as well. In this case, they have frequency. It summarizes a dataset consisting of 25 values. The first bar represents the frequency of values greater than or equal to 30, but less than 40. Now, you have to be careful. They are specifying in the first interval, the values are greater than or equal to 30, but less than 40. 30 is included, 40 is not included. Okay, in the first interval. In the second interval, 40 is included, but 50 is not included, and so on. How many values in the data set are greater than or equal to 50, but less than 80? 6 plus 2 plus 5, and that's it, right? So between 50 and 80, you have 13 values. 6 plus 2 plus 5, that's 13. Does that make sense? Sorry, yeah, that's correct. 6 plus 2 plus 5, yeah. Is that all right? Okay. Okay. Now, this is another diagram that you will see on SAT that's called a box plot. Now, a box plot looks like this. How many of you have seen this before? Okay. So some of you. So a box plot has two parts. There's a box in the middle that looks like this. And then you have two lines on the side. These are called whiskers. So it's called a box plot. Sometimes it's also called a box and whisker plot. You have boxes, one box in the middle and whiskers on the sides. On a box and whisker plot or a box plot, you just plot 5 values. What are those 5 values? The minimum value, lower quartile, median, upper quartile, maximum. These 5 values make up a box plot. Okay. One end is the minimum value, the other end is the maximum value. The box that you have, the box starts from the lower quartile, ends at the upper quartile. There is a vertical line in the middle like this. In the rectangle that you have in the box, you have a line that represents the median. Okay, these are 5 values that are used to make a box plot: minimum, lower quartile, median, upper quartile, and maximum. Now remember, minimum value, or let's start with median first of all. Median is 50th percentile, right? Upper quartile is 75th percentile. Lower quartile is 25th percentile. What does that mean? What does 30 represent? 30 represents that 25% of the values in the data are less than or equal to 30. This number 60, the upper quartile, that means 75% of the values in the data are less than or equal to 60. That's what percentile means, right? Upper quartile जो भी होगा उसका मतलब होगा 75% of the values in the data are less than that. Lower quartile is 25% of the values in the data are less than that. And similarly for median, it's 50% of the values. Okay? You should be able to interpret the lower quartile and the upper quartile like that. Okay? So these are the 5 values that you will see on a box plot. Minimum value, which is the smallest value in the data. Yes? Upper quartile कैसे find करते थे? 75/100 into whatever the total number of values is. Remember? 75n/100, yeah, 3n/4. You've done this in O levels, right? Whatever is the number of values, upper quartile tells you 75th percent position के ऊपर कौन सी value आ रही है, which means 75% of the values are going to be less than this number. So if you have a data set that has weights of something, 60 is the upper quartile. That means 75% of the values in that data are less than or equal to 60. Okay? These are the 5 values that make up a box plot. Minimum value, first quartile or lower quartile. 5 minutes. There's actually one whole topic that we still have to do, which we will नहीं करेंगे, वो हम नेक्स्ट क्लास में करेंगे, इसलिए लेकिन ये तो कंप्लीट कर लेना. नेक्स्ट क्लास में हमें प्रैक्टिस भी करनी है और वो भी कंप्लीट करना है. सो Saturday class, yes. अच्छा, just 3-4 more slides and then we end. Okay. So these 5 values make up a box plot: minimum value, lower quartile, median, upper quartile, and maximum. Okay. So these are the interpretations, value for which 25% of the data is less than this value, right? 50th percent median is 50% values are less than that. Upper quartile is that 75% of the values are less than that number. Okay. The rest we already discussed. So in this case, 25% values are less than 30, 50% less than 40, 75% are less than 60. Okay. Now, these are some features that you need to remember for a box plot. Sometimes you have outliers in the data. What's an outlier? Outlier is a value that's far away from the rest of the data. Outlier is a value that's away from the rest of the data. You will see in box plot sometimes there will be dots like this somewhere. Okay, these will be outliers. Or not like this, maybe, since the maximum are there. There might be dots like this. These are outliers that they are far away from most of the data. Is that okay? Sometimes it might be outside the whiskers as well. In that case, what actually happens is कभी कभी आपका data जो है उसमें कोई error, erroneous values आ जाती हैं. You ignore them, right? After ignoring them, you consider the rest of the data. उसमें से you choose the minimum maximum values, and outliers are represented outside the whiskers sometimes like this as well. So if you have the values outside like this, they're outliers. Okay, that's all that you need to know for now about outliers. The box that you have, remember what the box represents? The endpoints of the box, they are lower quartile and upper quartile. This gives you the interquartile range, the width of the box, right? Upper quartile minus the lower quartile, that's the interquartile range. Is that okay? If these whiskers are very long, like this, that means the data has a lot of variation, right? If the whiskers are small, like this, the data is not much varied. There's less variation in the data. Okay. So larger whisker means more variation, more spread in the data. Smaller whisker means less variation, less spread of the data. Is that okay? The box, if box is very narrow like this, that means these 50% of the values from 25 to 75, they're concentrated around the median. They're very close to the median. But if the box is bigger like this, they're not as concentrated, right? These are just some things to keep in mind. Sometimes they ask you, there might be 4 options given. Okay, इनमें से कौन सी interpretation correct है of a particular box plot? You should be able to figure out what to say based on the width of the boxes and also the length of the whiskers. Okay. Okay. 2 quick examples and then we end. 2 very quick examples. It's not going to take time. It's not going to take time. Just 2 minutes. The box plots summarize the weights in pounds of 2 sets of kettlebells, which of the following statements must be true. You can look at the box plots there. Look at the statements now. The number of kettlebells in set A is equal to the number in set B. Can you say anything about that? Box plots do not tell us about the number of values in the data. So this is not correct. We can't say anything about that. Median in set A is equal to the median in set B. Are the medians equal? One median is here and the other is here. They're not equal. This is also incorrect. The range in set A is equal to the range in set B. What's the range? Maximum minus minimum. That's not the case, right? That's also incorrect. That means B is going to be correct. Let's see what that is. The maximum weight in set A is equal to the maximum weight in set B. They're both equal, so that's correct. It's D. Okay? The maximum values are both the same. Okay. 2 datasets are summarized by the box plots shown. Based on the box plots, which of the following statements must be true? Must be true. Mean of dataset 2 is greater than the mean of dataset 1. The range of dataset 2 is greater than the range of dataset 1. Yes? Neither A nor 2? Neither 1 nor 2? B, 1 only? Yes? All of you agree to that? 1 must be true? Mean of dataset 2 is greater than the mean of dataset 1. Does a box plot even tell us anything about the mean of the data? It's the median of the data. This is median, not the mean. The data is spread like this. There's no way you can figure out if the mean for dataset A is going to be higher or B is going to be higher. Mean का कुछ भी नहीं कह सकते because we don't know the number of values. What about the range? Range of dataset 2 is greater than the range of dataset 1? No, it's the opposite. Range of dataset 1 is greater than the range of dataset 2. Both of them are incorrect. So it's neither 1 nor 2.